Hi, hello, welcome to your homeschool. This is your very important session of your class 10 mathematics NCERT or CBSE board. And this is very important session, children. In this session, we are going to learn about Pythagoras theorem and its converse, and one more theorem we are going to learn in detail here. So let's see the theorems. We have in our textbook only statement, but I'd like to prove this theorem also. Let's see the theorem here. Theorem 2.7. If a perpendicular means 90 degree, is drawn from the vertex of a right angle of a right triangle. First, what do we need here? We need a right triangle. So let me draw a right triangle here. This is right angled, and let me mark the letters A, B, C. If a perpendicular drawn from the vertex of right angle, this is a right angle vertex, right? From here, we need to draw a perpendicular. So observe here, what am I doing? Let me draw a perpendicular and mark this D. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle. See here, these two triangles are similar, and to the whole triangles, all the three triangles are similar is the concept, and to each other. So how do we prove this one? See, the perpendicular from vertex of a right angle to the hypotenuse of a right triangle divides two similar triangles, and these two similar triangles are similar to the big triangle. How do we prove this? First, we need to split the triangles. How can we split? So let me take here first triangle, big triangle, A, B, C. Okay, and then I'm going to see the D part. Look here, I just want to cut this piece here. Lift D and keep it here. What happens? So this will be right triangle D. Okay, as it is, this right angle place here. So that will be A, D, B. Yes, follow children. Only this part of the triangle I want to compare with the big triangle. So next, just we do this theorem proof in shortcut, right? This is the hypotenuse, and this is A, B, C. Now this piece, what I need to do? Actually, my right angle is here. So, this B piece lift and keep here. Why? I should get right angle this side. So, cut the piece, B lift up. So, what happens here? Like this. D is right angle and B here. Okay. So, D is right angle, B will be at the top. Now, same right angle triangle place here. D, B, C. Now observe here carefully. One more pair we need. Third one. What is that one more pair? These two triangles take, children. Third pair of right triangles are A, D, B, and one more right triangle B, D, C. So now, what we need to prove? We need to prove these two triangles are similar. Okay. So look here. These two triangles, observe carefully. Angle A, common angle. Angle B, angle D. What? Right angle. Right? Already given it is perpendicular. Angle B, angle D is right angle. Therefore, the two corresponding angles of a two triangles are equal by angle-angle similarity. What can I say, children? These two triangles are similar. Similarly, shall we see others? Look here. Angle B, angle D, right angle. Now which angle is common? Angle C. Angle C. Therefore, what I can say by angle similarity criteria, these two triangles are similar. Okay. See the next one. Angle D, right angle B common. Therefore, the two corresponding angles of two triangles are equal. Then what we can say? Therefore, the two triangles are similar. Yes, this is only the proof, children. It takes 4 lines for each figure, each case we write 4 lines, and then our theorem completes. Okay, if you want, you can do this proof also. But as per your textbook, they did not give you any figure or any proof was not there. So if you want to do, you can do this. And still one more I want to say in this. This is about a proof. But by this proof, we can get some corollaries. What are the corollaries? If they are similar, the ratios are in proportion. Do you remember this? If these two triangles are similar, children, let me start here. First case. So, observe these two figures. Which two letters are same in these two figures? I am saying a technique here. Okay, in this triangle, AB side there. In this triangle, AB side there. Okay, make sure where is that side in two triangles. Here, it is here. And here it is here, right? So what you need to do? Take these two sides proportion. So how we are going to take? Right here, children, if the two triangles are similar, the ratios are in proportion. That is AB by AD. AB by AD is equal to AC by AB. AC by AB. So observe here, we need to get one equation where you have a chance of asking in your examination. So now cross multiply AB into AB. AB into AB is equal to AD into AC. That will be AB square is equal to AD into AC is your equation. Okay, remember this. If any theorem asks to prove this, just to go for this theorem. Second case here. What is your second case? These two triangles already we proved similar. If they are similar, the ratios are in proportion. I don't want 3 ratios. I need only 2 ratios to get the equation. Which 2 ratios I'll take? Observe here, AB there, not there. AC there, not there. Yes, BC there in two triangles common side. So, BC is at the base and this triangle BC is at the hypotenuse. So, which two sides I will take here, children? Base and hypotenuse of two triangles. Compare BC by DC is equal to AC by BC. Okay. So now again cross multiply. BC into BC will be BC whole square is equal to, what are you going to get? DC into AC. So now third case here, what is that? These two triangles we have compared. Now again, these two triangles are similar, the ratios are in proportion. Which ratios we are going to take? Observe here, common side, what do you have here? AD there, not there. DB there, yes, DB is at the base and here perpendicular. So these two sides you need to take in proportion. AD by, yes, BD is equal to, what is the base? BD or DB, same children, BD by DC. Now again cross multiply. What you are going to get? BD square is equal to AD into DC. See, these are the 3 equations which are very important. See, these only we take to prove in our Pythagoras theorem. So once observe here, have to remember these. Have to remember this, children. Look here, AB square. Okay, here also how to remember, I'll say a shortcut. In a right triangle, if a perpendicular is drawn, so how to write direct equation without doing anything? If you know how to do, no need of doing always in some problems, you may apply this ratio. How to see the ratio in the figure? So look here, AB I am talking. Which letter is touching hypotenuse? A. Right? So small into big, you remember. What is that? Small into big. So AB square is equal to AD into AC. Is it there? Correct, no? So now, take this one. BC square. Which letter is touching your hypotenuse? C. BC square is equal to CD into CA. Or CD into AC also. See there? BC square is equal to CD into AC. And now coming to this one, perpendicular. BD square is equal to AD into DC. So once again, look here carefully. When any right angle is taken and a perpendicular is drawn from the vertex of a right angle in a right triangle, then you can say all the three triangles are similar to one another. If they are similar, the ratios I can frame some equations. What are those? AB square is equal to AD into AC. AD into AC. BC square is equal to CD into AC or CA. Which letter touching hypotenuse? Observe there from their part and whole. CD into CA or AC. Now this perpendicular, when I talk, only parts you need to multiply. BD square is equal to AD into DC. Okay, with one more figure, you are going to say all the three cases here. So now this is P, Q, R, and this is a perpendicular drawn L. Okay, without doing anything, write the three cases. How we are going to say? Look here carefully. PQ square, PL into PR. QR square, RL into PR. QL square, PL into LR. Similarly, you can do two more right angles and change the letter. Try to identify these corollaries. Yes, observe here children, this triangle is similar to this. This triangle is similar to this. And this is similar to this. So finally, what I can say, all the three triangles are similar to each other. Yes, now we are going to discuss very important theorem of your triangles chapter, that is Pythagoras theorem. Let's see the statement here. In a right triangle, so let's draw here right triangle. Okay, this is a right triangle, perpendicular. So in a right triangle, the square of the hypotenuse, where is hypotenuse? The side which is opposite to right angle, that side we call it as a hypotenuse. So let's mark here A, B, C. The square of the hypotenuse AC square is equal to the sum of the squares of the other two sides. That is the statement of Pythagoras theorem. What does it say? It says that in a right triangle, the square of the hypotenuse, so look here into proof, I'll write that. Square of the hypotenuse means AC square is equal to the sum of the squares of the, understand the statement? Hypotenuse square is equal to sum of the squares of the other two sides. What are other two sides? AB square plus BC square. This is the equation we need to prove. Okay, so let's start our theorem. What is that? By given data, given right angled triangle. See a right angled triangle, you can give the symbol like this also. Right angle triangle ABC. ABC. Right angle. Where it is right angle? At B. In right angle triangle ABC, it is right angled at B. Now, what to prove? Hypotenuse square is equal to sum of the squares of other two sides. Construction. Do we need any construction? Yes, we need construction. From right angle, draw a perpendicular. Let's mark D. Similarly, what we have done before theorem, same manner, but here only two cases we do for this theorem. So, what is the construction I have done here? Draw BD perpendicular to AC. Draw BD perpendicular to the AC. Next, how do we start our proof? Consider triangle. You can write right triangle also. Triangle ABC. Right triangle ABC. And what is one more triangle? Let's take this triangle. Cut the point here. D. Lift it here. Again, same manner. D is here. So try to place side by side. That makes right triangle ADB. This is right angled triangle ADB. So let me draw the figure here. ABC, big triangle, and one more small triangle ADB. ADB. Okay. Now compare these two triangles in triangle ABC and triangle ADB. So what I can say here? I can say angle B. Instead of writing only one letter, I'll write this. Angle ABC is equal to angle ADB. What is the reason? Perpendicular or given, or you can say by construction you can say. Okay, we made, this is given, angle B is given, angle D is, we have done the construction. This equal to 90 degrees, children. Next angle, angle A, angle BAC is equal to, angle BAC is equal to angle DAB. How we are saying that? This angle is right angle and these two angles are common angles of a two triangles, corresponding triangles. So therefore, what I can say? Right triangle ABC similar to right triangle ADB. By what? By angle similarity criteria. Okay, in always when we are writing theorem, children, these are all right reason side. Statement one side and reason one side we used to have before. But now, combinedly they are writing. Side beside this only we are writing. If you want, you can split reason separate and statement separate also you can do. Now, these two triangles are similar by angle similarity criteria. If they are similar, what do you remember? The ratios are in proportion. Which ratios? I said have to see the ratio. Only two ratios I want. How can you observe the ratio? So, in these two triangles, which side is common? AB, there in two triangles. Here, in this triangle, AB is here. And in this triangle, AB is at hypotenuse. So, try to take these two ratios in two triangles. So, let's take here AB by AD is equal to AC by AB. Now, cross multiply. AB into AB is equal to AD into AC. AB into AB. AB square is equal to AD into AC. Mark this first equation. Mark this first equation. Similarly, we are going to take another pair of triangles. What is another pair we are going to take here? Consider right triangle ABC and right triangle. See here, I have said, no children, how do you compare this triangle? So lift this D. Okay, if you lift this D and place here, you may get same manner, or you can lift this B and keep here, same manner you get. So lift this D and put it here, what happens? D, and this is right angle. So now this picture and with the big triangle place aside. So let me mark here, that is BDC. Now take the figure. A, B, C, and this one is B, D, C. B, D, C. Now what happened here? Observe these two figures. I can say A, B, C is equal to angle BDC. By what, children? Perpendicular means 90 degrees. Then next, is there anything common? Angle C is common. That means angle BCA is equal to angle DCB. What is the reason? This is the common angle. Okay, these two angles are 90, these two angles are common. Therefore, what I can say? Therefore, the two triangles are similar. By what criteria? Angle similarity criteria. I can say that right triangle ABC is similar to right triangle BDC. By angle similarity criteria. Okay, now if they are similar, what do we remember? The ratios are in proportion. Which ratios? Observe common side. Where is the common side here? BC. Right? BC is there in two triangles. So BC is at the base and here BC is at the hypotenuse. So which two sides? These two sides I need to compare. So let's take here BC by DC is equal to AC by BC. Cross multiply BC into BC. BC into BC is equal to AC into DC. That makes BC square is equal to, I may write DC into AC also, no problem. This is second equation. Now observe 1 and 2. AB square we got, BC square you got. But what I need to prove here? AB square plus BC square. So now what we are going to do? Just add the two equations. Add equation 1 and 2. What do we get if we add? AB square plus, left hand side add here, AB square plus BC square is equal to, now right hand side add, AD into AC plus DC into AC. So now in these two, what is common? AC is common. Take out common. AB square plus BC square is equal to, if you take out AC common, what you are left with? AD plus DC into AC. AC have taken common. What is AD plus DC? AD plus DC is nothing but AC, big line. AD plus DC is AC. So in this AD plus DC, substitute AC. AC into AC. AC into AC it will be AC square. Finally, AB square plus BC square is equal to AC square. Okay, if you want, any time you reverse the equation. So where shall we write here? So let me bring the equation here. AC square is equal to AB square plus BC square. Finally, Hence it is proved. Hence it is proved. With this we are going to end our theorem. See how we have started our theorem. From here we have done. Then from here to we have dragged the theorem here. Then continuation again came here. Okay. So let's have a okay, this theorem is very easy, children. If you understand, it is very easy. See, these two tiny figures what we have done, please erase after doing the ratio. This is just to identify. Actually, we observe these triangles in a single figure. But when we are observing, we may have a chance to do mistake. But if you split your triangles like this, you never do the mistake. Okay, so let's have a recap of Pythagoras theorem here. What is a Pythagoras theorem statement? In a right triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. Given it is a right triangle ABC and right angled at B. What is the construction we have done? Draw BD perpendicular to AC. What to prove? Hypotenuse square AC square is equal to AB square plus BC square. How did we start our proof? We have taken two pairs of triangles, ABC triangle and ADB triangle. We made them the two triangles similar. If they are similar, the ratios are in proportion. Which ratios to take also you should remember. No need of taking three ratios. Take only two ratios. That two ratios how to pick, children? Which side is common you see. So here what is common? AB. AB in this triangle there and in this triangle also there. So AB here and hypotenuse. So these two ratios of two triangles you take here, then cross multiply, mark it as a first equation. Similarly, take big right angle triangle ABC and this small right angle triangle. Again similarly prove 90 degrees common angle similarity criteria. The two triangles are similar. If they are similar, again the ratios are in proportion. Cross multiply, you are going to get the second equation. Now observe your proof. What we need to prove? We need to add this. Right? So AB square plus BC square, add these two. Then you can see something is common and AD plus DC is AC. AC into AC will be AC square. Finally, this is your proof. Hence, it is proved. See children, similarly this theorem was given by one more ancient mathematician. But his statement was little changed. What is that statement and who is that mathematician? His name is Pythagorean. So this theorem is also known as Pythagorean theorem. Sometimes it is also Pythagoras theorem is also called as Pythagorean theorem. What is Pythagorean statement here? The diagonal of a rectangle produces itself the same area as produced by its both sides. So observe here, if I take a rectangle here, diagonal, right? So what are the sides do a rectangle have? Length and breadth. So what does he says? Diagonal, length, breadth. According to his statement, diagonal square is equal to breadth square plus length square. So seeing this, again we remember that it is a right triangle, hypotenuse square is equal to sum of the squares of other two sides. So sometimes this Pythagorean theorem is also known as Pythagoras theorem. So what is his statement? The diagonal of a rectangle produces itself the same area as produced by its both sides. What are the both sides here? Length and breadth. That makes the equation diagonal square is equal to length square plus breadth square. So if any multiple choice asked, Pythagoras theorem is also known as, or sometimes Pythagoras theorem is called as dash theorem. That is Pythagorean theorem. Yes, we have seen a Pythagoras theorem, children. Now we are going to see about the converse of Pythagoras theorem. What is Pythagoras theorem? In a right angled triangle, the hypotenuse square is equal to sum of the squares of other two sides. Okay, in a right angle triangle given there. Now what is a converse? In a triangle, they did not give us right angle. See this. See here, they did not give us right angle. In a triangle, if square of one side is equal to sum of the squares of other two sides. And here they did not mention here hypotenuse. If they mention hypotenuse, that opposite angle will be right angle. We need to prove it right angle. So any one side square is equal to sum of the squares of other two sides given. Then the angle opposite to the first side is a right angle. We need to prove that it is a right angle. So same triangle we are going to take here. A, B, C. Okay, let's take it triangle. A triangle. If square of one side, children. So let me take this. Square of one side is equal to the sum of the squares of other two sides. That means in data. What I write? In triangle ABC. In triangle ABC, what did they give? Square of one side is equal to sum of the squares of other two sides. AB square plus BC square. Okay. So next step, what I need to prove, I will write. To prove first side opposite angle is a right angle, we need to prove. That means prove that angle ABC is equal to 90 degree or it is a right angle also you can write. So now next step, we need to do a construction. What type of construction we will do here? So observe here how to do the construction. What construction I do here? I'll give you the hint how we are going to prove the theorem. I'll take one more triangle. So let me take one more triangle here. Construct another right triangle, that is PQR. So I have taken a right angle triangle in such a way PQ must be equal to AB and QR must be equal to BC. So let's write here construction. Construct a right triangle. Construct a right angled triangle PQR where angle PQR is equal to 90 degrees or it is right angle, and in such a way PQ is equal to AB and QR is equal to BC. Now, how to start a proof here? So, observe here, I am going to say you before starting a proof, we are just going to discuss how we can prove this. Observe here, consider these two triangles. So, this right angle triangle, I can apply Pythagoras theorem formula. What is that? Square of the hypotenuse is equal to sum of the squares of other two sides. That is PR square is equal to PQ square plus QR square. But what is PQ? PQ is AB and QR is BC. In the place of PQ and QR, substitute these two sides. Then, on comparing these two, I can say PQ is equal to AC. Similarly, what I can say? Already we know these two sides are equal. This side is also equal. By SSS congruency, I can say these two triangles are congruent. If they are congruent, I can equate the remaining angles also. So now angle P, angle A, angle R, angle C, angle Q is equal to angle B. That is only the thing we need to prove here. That is angle Q is equal to angle B equal to 90 degree. That makes a right triangle ABC is right angled at B. Okay, let's start here. Consider What we need to consider here? We need to consider right triangle PQR. Okay? Apply Pythagoras theorem. PR square is equal to PQ square plus QR square. By what, children, this one? By Pythagoras theorem, I can say the statement. Right? So now, next step. In PQ, in place of PQ, I can substitute AB. AB square plus QR means BC square is equal to PR square. If you want, you can write like this whole square also, children, no problem. Okay. So now, what I have done here? I have substituted the values. Substitute PQ is equal to AB and QR is equal to BC. I have substituted, so I got this line. PR square is equal to AB square plus BC square. Let me mark this as first equation. What is given for us by given data? From given data, what did they give here, children? AC square is equal to AB square plus BC square. Mark the second equation. Now comparing first and second equations, things which are equal to the same thing are equal to one another. On comparing equation 1 and 2, RH is same, so you can equate LHS. PR square is equal to AC square. So, I can just write PR equal to AC. Squares can be cancelled. PR is equal to AC. How it is cancelled? That also you need know. AC square, this square send other side root and this side send other side root. Root will be cancelled. That makes PR is equal to AC. PR is equal to AC. So, what is this PR? This side, right? So, now, therefore, by S congruency, SSS congruency, all three sides are equal. SSS congruency in triangle ABC and triangle PQR. What I can say here? AB is equal to PQ, BC is equal to QR, and PR is equal to AC. Therefore, finally, triangle ABC is congruent to triangle PQR. If they are congruent, I can equate the corresponding angles. Therefore, angle B is equal to angle Q is equal to 90 degrees. What is angle Q? 90. If this is 90, then therefore angle B is equal to 90 degrees. That means angle ABC is equal to 90. Therefore, what you can say here, first side is a right triangle. It is a right triangle. By this one, how I have equated this angle, children? By CPCT. Okay, it is a right triangle. Hence, it is proved. With this, we are going to end our converse of Pythagoras theorem. Converse of Pythagoras is very easy, children. The same theorem you can prove in another manner. That is extending B and making one more right angle triangle, this triangle also you can compare. Common side AB you can take and you can prove. So with the two tiny concepts, we are going to end your session, children, today. So look here, Pythagorean triplets. What is triplets? Triplet means 3, right? So what is this Pythagorean triplet? Let's see the statement. If the three numbers which are the measure of three sides of a right angle triangle. So measures 3 sides measure, right? So right angle triangle are natural numbers, then they are called Pythagorean triplet. If they are natural numbers, then we say they are Pythagorean triplet. But on one condition. What is that condition here? The square of the hypotenuse means one side. If you square, you should get the sum of the square of other two numbers. So we have a general form for that. Look here, how can we identify Pythagorean triplet, or how can you frame triplets? How can you frame? So look here, general form for natural numbers, either it may be n may be even or odd. What is the general form? 2n, n square minus 1, n square plus 1. What is this general form? We have seen in arithmetic progression. Do you remember general form? Similarly, suppose if I take here 2, if you substitute in n place 2, what happens? 2 2s are 4. Look here, 2 2s are 4. Then 2 2s are 4 minus 1, 3. Then here 2 2s are 4, 4 plus 1 will be 5. So I can say 3, 4, 5 is a Pythagorean triplet. How can you say, children? So which is the biggest number here? 5. So in a right triangle, this must be a hypotenuse, and like this. If you square this and see, 5 5s are 25, 4 4s are 16, 3 3s are 9. 16 plus 9 is the square of the hypotenuse, that is 25. So therefore these three numbers or three values form a Pythagorean triplet. Similarly, you can check any odd number, even number you may check. If you want, you can say 3. Substitute in place of n 3, 3 2s are 6. 3 3s are 9, 9 minus 1, 8. 3 3s are 9, 9 plus 1, 10. In these three, which is the biggest number? 10. So square it. So observe here now. Let me write the sides. 10, 8, 6. 10 10s are 100. 8 8s are 64 plus 6 6 are 36. Then 100 equal to 100. Therefore, it forms a Pythagorean triplet. Okay, this is a general form, children. Just you know the statement enough. Okay. So similarly, when only odd numbers, if I ask you any question, only odd numbers, frame 10 Pythagorean triplets of odd numbers, I say. So at that time, what is the general form? N, half of n square minus 1, half of n square plus 1. Okay, same manner. If you want, you can take one example here. Let's take one odd number, 3. Okay, 3, 3 3s are 9, 9 minus 1, 8, 8 by 2, 4. 3 3s are 9, 9 plus 1, 10, 10 by 2, 5. Is 3, 4, 5 a Pythagorean triplet? Yes, it is a Pythagorean triplet. So, this general form, these three values you can take for any natural number of odd or even. But these three you can take only for odd number. Next, one more. Know this concept I have given here, children. If in a right triangle, what do you know? One angle is 90 degree, then square of the hypotenuse is equal to sum of the squares of other two sides. Okay. If that right triangle angle is acute, how do you frame the equation, children? I can frame the equation like this. So how? Let us take first one right angle triangle. Right angle, let be A, B, C. Hypotenuse is B, means apply Pythagoras theorem. B square is equal to A square plus C square. Okay, when this is right angle. So now make this angle, reduce this, compress the angle. If you compress, what happens here? This angle will become acute. I am talking about one angle. One angle is acute. Okay, so in right triangle what happens? If one angle is 90, then other two angles will be acute. So here, if this right angle is acute, if this becomes acute, then what happens? How do you write the statement? In triangle ABC, not right. In triangle ABC, angle B less than 90, then your Pythagoras statement also you can write it as with less than, not equal. AC square, that means hypotenuse square is less than square of sum of other two sides. That means BC square is less than C square plus A square. Suppose the same angle, if it is increased more than 90, can you see here? It makes an obtuse angled triangle. If it is obtuse, how do you write the relation here? In triangle ABC, angle B is greater than 90 degree, then AC square is greater than AB square plus BC square. That means hypotenuse square is greater than other two side square sum. That is B square is greater than C square plus A square. Okay children. With this, there is an end of important theorems, children. In our next session, we are going to continue with this exercise. We are left with only one exercise. Okay, children. Thank you all.